This is on quadratic inequalities. We have got 9 questions, so let's look at one by one. Question 1, x squared minus 7x plus 12 is greater than 0. Let's write it as an equation. X squared minus 7x plus 12 is 0. We can factorize this. This is 4 times 3. So we could write it as x minus 4 times x minus 3 is equal to 0, which means x minus 4 is equal to 0 or x minus 3 is equal to 0. That means x is equal to 4 or x is equal to 3. Let's put this in the graph. So let's take this as 3. Let's take this as 4. So how would the graph go? The graph would go like that. It's a parabola graph. X squared graph is a quadratic graph, is a parabola shape. But in the inequalities it says this is greater than 0. So where would this graph, which part of the graph will show the y value greater than 0? We treat this is actually y. The graph is y is equal to x squared minus 7x plus 12. If y is 0, this graph, in which part of the graph shows y value greater than 0? So this is where the y value is 0. So anything about this line, part of the graph, the y value is greater than 0. So as you even if you extend the graph, all the values of y you will see is greater than 0. Therefore, how do we write the inequality? We could write x is greater than 4 and x is less than 3. This is what that actually satisfies the inequality. You could write together, if you want to write together, that will be x is greater than 4 but less than 3. You could write it like that as well. Let's look at question 2. Similar question. Again, we will factorize this. X squared minus 2x minus 35 is 0. We could do 5 and 7. So we could say x minus 7 times x plus 5 is equal to 0. Which means x is equal to 7 or x is equal to minus 5. We can show it in the graph again. Imagine that's minus 5 and this is 7. So the graph will go like that. It's less than 0. So where would the y value is less than 0? Below this point. That's the x-axis. That's where y is 0, below this point. So the part of the graph we need to highlight is this. So if you look at that this way and this way, we could write the inequalities. X is less than 7, sorry, and x is greater than minus 5. X is less than 7 and x is greater than minus 5. Question 3. Question 3. X squared plus 6x minus 40 is greater than 0. So again, x squared plus 6x minus 40 is equal to 0. We can factorize it. That is 10 and 4. So we could write x plus 10 times x minus 4 is equal to 0, which means x is minus 10 or x is 4. Again, we'll draw the graph. That's minus 10. This is 4. The graph will go like that. Right. So which part of the graph you're going to highlight? is actually greater than 0. So this part above this line is greater than 0. So the highlighting part is this. So how do we write the inequalities? X is less than minus 10 and x is greater than 4. Let's look at question 4. Question 4 is x squared minus 3x plus 2 is less than 0. So this is 2 times 1. We could write x minus 2 times x minus 1 is equal to 0, which means x is equal to 2 or x is equal to 1. So let's do that. That is 1, that is 2. The graph is going to go like this. So which part of the graph satisfies the inequalities? Less than 0 is below this. So that's the less than 0 part. So we're going to look at that and look at that part. So how would we write it? X is less than 2 or x is greater than 1. Question 5. X squared minus 8x minus 9 is 0. So we can do 9 times 1. So we factorize x minus 9, x plus 1 is equal to 0, which means x is equal to 9 or x is equal to minus 1. Same thing, you can plot the graph like this. This is 9, this is minus 1. So we're going to draw the graph again. Graph is going to be sketched like that. So we want to find the greater than. So which part is greater? This part is greater, above 0. So the part of the graph that we're going to highlight is this part, this direction. So the inequality, we could say x is greater than 9 and x is less than minus 1. Question 6. Question 6 is similar, but it's got minus at the front. So if it's a minus, the graphs always go like that. It's reflected in the x-axis. So we're going to bear that in mind. So what we're going to do is, to do that, what we'll do is, we'll take the minus out. It's easier to draw. So that becomes x squared plus 2x minus 15 is equal to 0. We keep the minus out and we'll factorize this. 15 is, we could say 3 times 5. So we could say x plus 5, then x minus 3 is equal to 0. So that means x is minus 5 and x is 3. But we know the graph is going to be the other way around anyway because of the minus. So we're going to draw the graph, and this is minus 5 here, this is 3. So we're going to draw the graph like that this time. And which part is going to satisfy that? This is less than 0. So where is y value less than 0 is this part. So it will be this. So it will be x is less than minus 5 and x is greater than 3. Let's look at question 7. Question 7, x squared minus 14x plus 40 is 0. So we could do 10 and 4. So that be x minus 10, x minus 4 is 0, which means x is 10 or x is 4. Again, same thing, 10 and 4, so that is 4, that is 10. So the graph is going to go like that. So we're going to highlight the 10 and 4, but you know this is greater, so this is the part of the greater part, so this is where the greater is. So therefore x is less than 4, and also x is greater than 10. So these are simple questions, but we're going to try and put two inequalities together and find the set of values for x, for which x squared minus 81 is greater than 0 and x squared plus 15x plus 26 greater than 0. So let's look at this. So we're going to do two different ones and we put it together. So first thing what we're going to do, we're going to do x squared minus 81. We could say x squared minus 81 can 0. We could write this x minus 9 times x plus 9. We are bringing something that we learned before, which is a squared minus b squared can be written a minus b times a plus b. Same thing, x squared minus 9 squared, because 9 squared is 81, can be written x minus 9 times x plus 9. So this here, so x could be plus 9 or x could be minus 9. We can show that in the graph here. Let's show it in a little graph. That's minus 9, that is 9. So the graph goes like that, and it is greater than 0. So it's greater than 0 means we are going to show this is where the greater than 0 is. We're going to show that part. So for this one, we would say x is greater than 9 and x is less than minus 9. Then we have put another one to deal with. So let's deal with that here. That is x squared plus 15x plus 26 is 0. 26 is 13 times 2, so we could write x plus 13 times x plus 2 is 0. That means x is minus 13 or x is minus 2. We can show that in a little graph as well, so we can put it together. So let's draw that graph. Let's do that again. This is minus 13, this is minus 2. So the graph is going to go like that and is greater than 0. So we know the greater than 0 is that part. So it has to be that and that. So we could say here x is greater than minus 2 and x is less than minus 13. We have got two inequalities. So if we want to find the set of values for that, we just look at a number line. Let's take a number line here. Let's just draw a number line there. We'll plot these points here. So this is say minus 13. This is, we have a minus 9 here. That's minus 9. This is say minus 2. And we have 9 there. So this is probably 0 and 9 is somewhere here, right? For the first one, x has got to be this graph, x has got to be greater than 9. So I'm going to put a circle because there's no equal sign, greater than 9. X has got to be less than minus 9. So I'm going to put a line like that. For this graph, we'll put it in red. X is greater than minus 2. So and x is less than minus 13. Now, so we need to find the set of values for x for which both of the inequalities are satisfied. Right? To do that, what we are going to do is now, we can, by looking at it, we know both of them only satisfies this part and this part. Therefore, the set of values that satisfy both inequalities would be x is greater than 9 and x is less than minus 13, because these are the numbers both graphs overlaps. this satisfies both graphs. So therefore the set of values would be that. Do one more question, that is shading. Let's do a bit of shading on this. Shade the region that describes the following two inequalities. Okay, we have done this before, so we're going to use the same knowledge here. So that is x minus 9, x plus 9 is 0, which is x is equal to 9 or x is equal to minus 9. So we're going to draw that in the graph. As the graph, we have minus 9 and plus 9. So that graph is going to go this. And the inequalities that satisfies, because it's a greater than 0, we know this is this part up the top, so that is what satisfies that inequalities. Then we have another one, which is y is less than 9. So let's mark 9 here. So 9, we'll say, let's say here 9 is less than 9. So which part is, this is y is equal to 9. I'm going to draw the y is equal to 9 here. It's a straight line. So which part is y is less than 9 is this part. So we're going to satisfy both. We know for this one the graph is that part. For the first inequalities, the graph is, this is what the areas we set. For the next one, y is equal to less than 9 is downwards here up to x-axis. So what we could do, we could color that in. This is the region that describes the two inequalities. Region shaded. Right, there's 9 questions there. So hopefully you all understood that.